I would like to present our research work is titled The Displacement Simulation for Cracked Earth Structure is Different Geometry. The work is combination of the analytical method and numerical simulation using FEM software. This work are divided to the 5-part highlight, introduction, method for simulation, outcome and explanation, and at the finally conclusion of the research work. Highlight. The clay soil backfill is modeled when the clay soil backfill is content of the crack due to material is using for construction of this backfill. Then nonlinear displacement magnitude and distribution is investigated after simulation based on the numerical simulation, analytical method, and statistical modeling, and crack interaction for model are investigated when changing geometry of the model. Introduction. The mechanical property of the model is responsible for the strength and stiffness of the model. In the general, when we use the sand, we have high permeability, and when we use the clay, we do not have permeability, but this advantage is creation of crack on model. The creation of the crack on the model is depend on several factors. One factor is considering here, which is the geometry of the model. When the changing geometry of the model, how is changing the seismic response of the clay soil backfill based on understanding crack and interaction and load interaction, and how crack growing for a displacement of the model. The main objective of here, we have two model with two different geometry. We want to know the geometry of the model, how is impact on the model, and the cracks in the crack zone. Based on the analytical analysis, we identify crack zone and the solid zone, and we calculated the crack zone for both model, higher geometry and lower geometry, and nonlinear displacement of the model in both loading and preloading stage have been studied to understand the seismic response of the clay soil backfill. Method of this simulation. Method of this simulation in any earth structure, based on the geomorphology of the site, we need to select a different size of the earth structure. But here we assume two model, one is bigger and second one is smaller, and we not consider any case study for this investigation because we want to know exactly impact of the geometry of the model when all parameters are same. We are considering only one parameter is changing in modeling, which is the geometry of the model. The model is contained of two parts, the crack zone and solid zone. The crack and solid zone will be calculated based on the analytical method, which are reported in the literature, and seismic loading. Seismic loading is applying to the model is exactly what we have in the field, and we not simulated any laboratory simulation because when we use the seismic load is recorded in the site, it will be more realistic for the simulation and understanding seismic response of the model. Two model here. We have one is the model with higher size, model 2, and model 1 is with a smaller size. What interesting is here in both model 1 and 2, we have the crack with same length because length of the crack is calculated based on the mechanical property of the modeling, based on the mechanical property of the soil. Here is showing the acceleration we applied on the model in 3 directions, X, Y, and Z simultaneously is applying to the model using Abacus software. What we have here, we have the flow chart is start to the end based on methodology and conclusion. We have here all thing is showing in this part. Outcome and explanation. Result, what we understand here based on the single stage and whole stage of the numerical simulation. Single stage, we selected final stage of the numerical simulation, and whole stage is from the initial of applying load up to the end. And load transmission, displacement, magnitude, distribution, as well as the vibration of the model are studied. Vibration of the model is related to the crack interaction and displacement of the model. Nonlinear displacement of the model and the crack interaction are responsible for the vibration of the model, vibration mechanism, and damage is occur on the model. What we have here in final stage of the numerical simulation, we understand displacement in this stage. In the model 1, we have higher variation of the displacement, and in the model 2 is lower. And load transmission are responsible for this kind of displacement. In the statistical modeling, we use data from all stages of numerical simulation, and based on the loading and reloading for both model 1 and 2, the displacement are simulated. What we can observe here, nonlinear displacement in the model 1 and model 2. Nonlinear displacement in model 2 is higher both in the loading and reloading, and magnitude of the displacement in single stage in model 1 was higher, but here in the whole stage when we are considering, we can understand the model 2 has higher nonlinear displacement. The tensile and compression strain of the model 1 and 2 are showing in this picture. What we have here in the model 1, most of the compression and tensile strength are occur around the crack, which is not observed in the model 2. The geometry of the model is impact on crack interaction of the model and strain distribution in the model. It's in the final stage, but if we want to consider whole stage, also we can find the model geometry are very important to tensile and compression strength developing on a model. A conclusion. The concept of nonlinear displacement of the model in both loading and reloading stage was supportive of the Earth's soil design. The load transmission and crack interaction have a meaningful relationship. The geometry of model modified crack interaction and displacement, magnitude, and distribution. The mechanical property of model change related to the geometry of the model. In the initial of the numerical simulation, we use same mechanical property for both model, but with applying the load, the geometry of the model is responsible for changing mechanical property of the model. Thank you for attention.